All right. So words are hard, math is easy. A lot of words here. We want to tell which center these are, right? The name of that center. We want to talk about where it is located. If the triangle is an acute triangle, like the one I've given you, a right triangle, like one that we'll draw, or an obtuse triangle, right? We also want to talk about what segments did I use to find that center, right? So what do we call these lines that I drew? And then we're going to also talk about any special properties those lines might have. So let's look at the first one. First off, this first one here is made up of these lines. Now if you notice how I labeled them, right, down here and down here, these angles are congruent, these angles are congruent, and these angles are congruent. That's trippy looking, isn't it? It's great. All right. So what kind of lines are those? Does anybody remember what those are called?
Medians?
Nope, not medians. Remember, median is vertex to midpoint, and that's not a midpoint. We don't know that that's half and half. We know the angles are cut in half. Something with a C? All right, so you guys all remember medians really well, because that's the one we took the small quiz over, right? Remember medians are what? What's a median? Vertex to midpoint. Here's the vertex. Is that traveling to a midpoint? No, it's not labeled as such. It might look like it over here, right? Looks pretty close, but it's not labeled that way, so we don't know that that's the midpoint, right? We do know these angles are being cut in half. What does it mean to cut something in half? What's the word we use? Bisect. So these are angle bisectors. Does that make sense? So it's not median, it's not centroid, right? Those go together. These are angle bisectors. So first of all, we're going to write angle bisectors. That's what we're looking at here. Now, does anyone remember? I bet you don't, but if you do, that's great. Does anybody remember what that center is?
Centroid.
Intersection. No, centroids with medians, right? Centroids with medians. We're talking about angle bisectors.
Midpoint.
Is that like something?
Angle bisectors cuts it into two congruent angles. Cuts it in two congruent angles.
Intersection.
So it's the what? Cuts it in to two congruent angles.
What center?
Huh?
Oh,
The
In center.
in center.
Okay. The in center, you can remember the way she was talking about just there, right? But also, on top of that, the in center is the center of the triangle, but it's also the center of a certain circle. Is the circle on the outside or on the inside, you think? Inside, right? That's why they call it the in center, right?
No.
So there's a circle in here that fits perfectly, and its center is G.
Oh, it's
Okay? So we have the in center. And we're going to write it is the center of an inscribed. Inscribed means inside, right? Inscribed circle. Inscribed. Scribed means to write. In means inside, right? Inscribed. Inscribed. I'll write that in print. Okay? Inscribed. Circle. So if we were to draw that on our diagram, it looks something like this. And again, I'm drawing it freehand. GeoGebra is a better way of doing it, of course. Right? It's going to look something like this. Let's see if I can. Like that. A perfect circle with the center of G. Right? Gross looking. But that's the idea. Okay? Now, remember, circles are things that have a center, right? And then from that center, does anybody remember what that line's called from maybe a couple years ago? Radius, right? And the radius is the same no matter where you go, right? It's the same amount from everywhere. So what this center has is it has lines that go to the side here, right? That are all going to be the same distance. So those lines are all the same distance. So this center is the same distance from every side, right? Because it's a circle. That's what a circle is, right? It's the same distance out from the point, right? So from here to here is the same from here to here, same from here to here, right? So the same distance to every side. Now, how do we choose which one to go with? Well, we go with the one that intersects, and it's going to hit at a 90-degree angle. Those are 90s. Remember yesterday, in order to make the circle, we had to do a perpendicular, right? A 90-degree. And then we found out how long it needed to be, and then we made our circle. So that's what we've got going on here. So that circle has radii going to the sides of the triangle, and they hit at 90 degrees. I don't need you to write that, I just need to see it. Okay? We're going to go into GeoGebra and do this again, and hopefully that'll click again, right? But this is your study guide for that. So how do I know it's the incenter? Angle bisectors, right? Angle bisectors hit at the incenter because it's the internal circle. And inscribed circle. And circles are the same distance to every side, right? That's the idea. So let's see what we got. What center is each diagram portraying? Check. Where the center is located when the triangle is acute, right, or obtuse. Haven't done that, right? That's an acute triangle, right? So when it's acute, where's the center located? Inside, outside, or on it?
Inside.
Inside. All right, trick question. If it's a right triangle, where would it be?
On the 90 degree, like on the 90 degree
Outside.
thing, right?
On the side, you thought about that, you said on the 90 degree. I know that it's still on the inside. How do I know that? Not because I memorized it. Why does that always have to be in the inside, no matter what triangle we're talking about? Huh? Not quite. Why do we know that that center always has to be inside the triangle?
Otherwise, the circle wouldn't work.
Level. Balance.
No. It's something we already talked about.
The circle.
Why do we call it the incenter?
Because the circle's on the inside.
Because of the center of the.
Because the inside circle is the center, right? So it's always going to be a circle on the inside. If the circle's always on the inside, where's the center of the circle going to be?
Inside.
Always on the inside, right? If the circle's always inside here, then the center of the circle is always going to be inside. So for all of these, it'll be inside. Acute, right, obtuse, did it. What segments are used? Angle bisectors, right? Those are the guys that make the center. So we've done that. Special properties. From G to any of the sides will be the same distance, right? Because it's a circle. And it hits at 90 degrees. Check. Now that's one of the more complicated ones, right? We know about medians and centroid, right? That one we're pretty comfortable with. This next one is not very difficult either, okay?
Do you want them to draw the circle and put those perpendiculars in there?
If
Or
you're
do
talking
you
about
just want them to write center
good
of
question.
an inscribed
Good
circle?
question. If you're talking about the circle over here, I don't need you to draw it over here. So you have an option. You can either draw the circle or talk about the circle
So
over
you
here.
put center of an inscribed circle would be enough?
That'd be enough. That'd be fine.
Okay.
You said all of them are 90?
All of these lines going out will be 90. Yep. And all the same length. Yep.
Why not going up?
What?
Why isn't like one going up?
This one, and this one?
Oh, like you're not.
Because they go to the side. So this goes to this side, that goes to that side, and that goes to that side. Right? Cool. So the distance between the center to the sides is always the same. And it's always the same. I know that because there's a circle inside here, and circles are always the same distance, right? Radius, right? And when we hit it, it hits at 90. That's how we measure stuff, to a 90-degree angle. So like the distance between these two pens, I would measure straight across because that hits it at 90, right? The distance from here to here, I'd have to measure differently because it would be at 90. So from here to here will be 90, here to here will be 90, here to here will be 90, and they'll all be the same. Okay, cool. That's one of the harder ones. So angle bisectors, how do I know it's angle bisectors? Well, it's bisecting the angles, right? Now, if I do that, it's always going to be in the middle. So I've got an internal circle in center, right? In center, in circle, inscribed circle. Circles are always the same distance to the outside. Let's look at number 2. All right, let's talk about what kind of lines I've drawn. What do you notice about those lines? What do you notice about them?
They're making 90.
They make 90, right? So they're all perpendiculars. They're all heights. We have a lot of names for this one, right? Those lines are heights, they're perpendiculars. What else we got? What else we got? Remember, it's the one that has a bunch of different names for the lines?
Angle bisector.
Start with C.
Nope, no C1, I can't think of that one. Not angle bisector, we're not cutting any angles in half. Ortho something, that's right, braces bust, right? So we have orthogonals. Anybody remember the last one? Has to do with mountains. Height on the mountain?
Spell word.
Peak. Nope. Peak's the very top. I want to talk about the height of the mountain. You go to Colorado.
Elevation.
Huh? Elevation, that's good, but that's not what we call it. I wish we did.
Altitude.
Altitude. Altitude. I wish we did, Tucker. Altitude. Any of those I will accept. Now, the best one probably is orthogonal because it's going to help you remember what that center is. What do we call that center?
Center.
What center? Something center.
The end.
Orthogonal is going to help you memorize it.
The
Eves.
end center.
No, we already did the in center.
There's different names for every triangle.
Yeah.
What?
For each type.
Right? It's something like that, isn't it?
It's something with ortho, right?
Yeah, it's like,
The ortho.
I love that song.
Oh my gosh.
That's right.
You are right.
The ortho center.
Oh,
You have the in center because the circle's inside the triangle. You have the ortho center because it's
What are these
inside.
dumb names? I'm not reading this stuff.
I thought of that and I didn't
Because you
say
gotta make
it.
them straight, like the
I
teeth
see this
straight.
other.
Orthogonal, perpendicular.
So is it called that because it's not in the center like number one was?
So, depending on what lines we draw on our triangle, right? See how those are the same triangle here and here? These are the same triangles. But if I draw angle bisectors, they intersect here. If I draw my orthogonals, my perpendiculars, my altitudes, my heights, whatever you want to call them, right? They intersect here. So they're different center names for that. The center here is the in center because it's the inside of the circle, right? In center, right? This is the orthocenter because it's the intersection of our orthogonals, right? We could call it a lot of different things, but probably the most helpful thing to call it, these lines, would be orthogonals. It's kind of a crazy name, right? But it just means perpendicular or right angle or height.
So it doesn't mean don't draw a circle?
Nope, no circle here, right? If you try to draw a circle, would you be able to with that being the center? No way. Center of that circle is like here. Wouldn't hit all the sides, right? The orthocenter isn't really that interesting. It doesn't have a lot going for it. There's stuff, but it's really complicated stuff, and we're not going to worry about it, like super complicated. So for the most part, we're just going to leave it alone and say, that's it. That's all we got. Okay. So like I said, this one's a little bit easier than the last one, right? It has less information. So let's back up and talk about the last one. Last one, what are these sides, these lines called that I drew? Angle bisectors. How do you know they're angle bisectors?
Because they don't meet, like, you're like, it's not in the middle, so it's not in the
Oh,
point.
because they cut those.
They cut the angles in two. They bisect the angles, right? Yep, you're thinking big brain play,
Yeah.
right?
I don't know.
Simple play. Angle bisectors because they cut the angles in half. That's what bisect means, right? So those are angle bisectors. Where they intersect is the in center because that's the center of an internal circle, inscribed circle, right? These are orthogonals. You can also call them heights, perpendiculars, or altitudes. I'll accept any of those, but probably the best one to know is orthogonal, right? Even though it's a crazy word, because it helps you remember the center. It's the center of the orthogonals, orthocenter. Braces bust. Ms. Bechtel mentioned yesterday that when you go to the orthodontist, right, they straighten your teeth. These lines, 90 degrees, straight up, right? Orthocenter, orthogonals, okay? Don't worry, we're gonna go back and re-hit each one. And we'll take our time.
Is that all we had? Is that
You
all
have
we
to
had?
That's
do
it,
the-
there's
you
nothing.
have to do
Oh, we gotta do
the
one more thing, yep.
acute.
Acute, sorry, thank you very much.
Wow.
Right. Obtuse.
You have to write all of those?
There's
Okay,
three different
always
kinds of
in.
triangle. The question is, where does this end up? For this one, it's always on the inside.
That's all we have to do right now.
There's not a whole bunch. It'll be okay.
The acute is on.
It's all on the inside, right? For this one.
the inside.
This is an acute triangle. Looks like it's on the inside, right? For a right triangle,
Inside.
isn't that a right triangle?
Yeah.
If I cover that up, it would intersect at here at the right angle. This is the one Ivy remembered earlier. They're going to always intersect at the right angle.
Aren't they? Isn't everything always going to be inside?
No, this one's on the right angle.
steps
In
and
a
then
right
still.
triangle, one of your altitudes is inside.
Can we just put like 90 for our answer, or do we have to put right angle?
I'll understand what you mean if you say
Okay.
90. That's fine. Again, I'm trying to help you get the right answer here, right? I'm not going to be like, well, that's not exactly what I wrote, right? If it makes sense, then that's an
Okay.
acceptable answer. You understand it, right? That's what I'm trying to check here. Now remember, you're going to have GeoGebra while you do this, right? So if you can't remember if it's on the right angle or not, make your perpendiculars, make a right triangle, and see where it ends up. That's why we're doing the stuff that we did the last couple of days. I think some of you guys didn't take it nearly as seriously as you probably should have, though, right? That's okay. We'll figure it out. Obtuse. If it's an obtuse triangle, right? Acute's on the inside. On the right, it's going to the right angle. So if I keep making it bigger, it's going to keep heading that direction, right? Where's it going to be? Inside, on the right angle, and then it's going to be on the outside, right? I can show you that without GeoGebra right now. Let's do big. So that triangle right there is obtuse, right? The height of that triangle would be like this. That would be the height from bottom to top. Do you guys see that idea? From bottom to the top of the triangle, I'd have to go like that. So it ends up being on the outside. Right angle triangle. Height's right there, right? There's my age, my height. Internal, there's the height of the triangle. Okay, that's for the acute. Again, you'll have GeoGebra to experiment with tomorrow, and we're going to do that at the end of class to make sure you guys are familiar with that. 3. Woo! We got a lot of information here. First of all these lines are 90s, right? So we're talking perpendiculars, right? Perpendicular. Not only are they 90 degrees, but what do we know about point E, point D, and point F? What kind of points are those?
Midpoint.
Midpoints, right? So we got midpoints and perpendiculars. So what these are perpendicular. And they bisect the other side, right? That's what a midpoint is. It cuts it in 2 equal pieces. So perpendicular bisectors. Big word, it means 90 degree cuts in half. 90 degree cuts in half. Cool with that? We had angle bisectors before because we bisected the angle, right? Cut the angle in 2. Now we're bisecting the sides, perpendicular bisector. Okay. 2 things, 90 degree, cuts in half, bisect. So we have perpendicular bisectors. And they're going to intersect at this point G in the middle there. So already you can tell for an acute triangle it's going to be on the inside, right? Spoiler, all acute triangles are going to be on the inside. So what do we call this thing? Perpendicular bisectors. Well, we know it's not the centroid, right? Centroid goes to median. We learned that very early on. We know it's not the incenter. We know it's not orthogonals. The last one we have is circumcenter. You guys remember that from the other day? That huge word? Circum means to like go around in a circle, right? On the outside, you circumnavigate the world, right? So what this is going to be the center of is the center of a circle that goes around our triangle. So circumcenter. I'm going to draw that circle as best I can. I suppose I could get a compass out and you can see that I guessed on that guy. That's not bad. Do you see how G is the center of a circle that goes around the outside, right? It hits all of our vertices perfectly. So this one's kind of like if you want to put a circle inside a triangle, that's how you do it, right? If you wanted to put a triangle inside a circle, you do it this way. So we call it the circumcenter. It circumscribes it. Okay? Think
Are
circumference.
those lines on the outside of the triangle for a reason? Or is that like...
Notice that these just kind of go off at 90, right? They're not always going to hit the vertices, right? All of these stayed inside, right? They always stop. They hit a side or something at a certain point, right? These ones, they just keep going. So we start at the midpoint and then draw straight up. Could I have stopped it? Sure. But I didn't want you to think that's a special point, right? It's not. It just keeps going, right? The bottom is where it cuts it in half, right? And then it keeps going. Good
Why
question.
is it perpendicular?
It's perpendicular because these are 90 degrees, and perpendicular means 90, right? Before, we called these guys perpendiculars, right? Because they all hit at 90. But probably the better way to call them is orthogonal because it kind of goes with the word here, right? That's a memorization thing. All those are acceptable names. Orthogonal is the crazy one, and it's the one that goes with the name of the circle. Okay? But orthogonal means perpendicular, which means 90. Okay? So all those go together. Now, think about it. If we have a circle, if I draw a line from here to where it hits the circle, the vertex, and here to where it hits the circle, the vertex, and here to where it hits the circle, what do we know about all those purple lines? It's a circle. That's the center of the circle.
Oh,
The central medians.
Not angle bisector. Remember that cuts an angle in half? They're not cutting any angles in half.
The
Okay,
medians.
good guess though, right? It looks like it's kind of half. What are they really?
Medians.
Nope, not medians. That's a different thing. Think about it. I've got a circle, and I've got a bunch of lines coming at it from the center. Radians. Yeah, radius, right? These are all radii. That means they're all the same length, right? So this right here is the same length as this right here.
You got to show that.
Yep. Same as this right here. Again, how do I know that? Not because I've memorized anything, but because I know I've got a circle and that's the center. So from the center to the circle, that's always going to be the same, right? That's a radius. These guys will always be the same. Okay. So let's go back and back up over these things.
Alright, missing shit on the
Is that all
bottom.
you have to put for?
Oh, sorry, not that. But I just wanted to go back and refresh. So these guys, angle bisectors. Why do I know that's an angle bisector?
Cuts the angles.
Cuts the angles in half. So we call them angle bisectors. Bisect means cut in half, right? What do they cut in half? Angles. Why do I call it the in-center?
There's
It's
a circle in the center.
circle in the center, right? There's a circle inside the triangle, so we call it the in-center. Now, if the circle's always inside the triangle, and that's the center of the circle, is the center always going to be inside the triangle? Yeah, because the circle's always inside the triangle, so the center always is. So, yeah, a lot of information, but if you know what it means, it kind of flows, right? Angle bisectors because it bisects the angles. Center of the circle inside, so inside. All of these are going to be inside because the circle's always inside, the center of the circle will always be inside, right? Lastly, we know that these guys are all the same length because they're radii, right? It's a radius, and they hit at 90. That's kind of the weird one to forget about, okay? So there's a lot, but that's the one I would focus on if I'm studying, right? This one. Weird name, but orthogonal just means perpendicular, which just means 90 degrees, right? So these are all orthogonals, right? Because they're 90. So we call it the orthocenter. Orthocenter is kind of boring, kind of like going to the orthodontist. Not a whole lot of cool information about it, nothing to add, right? But it's on the inside when it's acute, as we can see here. It's on the right angle here, right? It's the height of the triangle. And it's on the outside here, right? From bottom to top, we got to go on the outside and measure that. Okay. This one, perpendicular bisectors. Why? Because they're perpendiculars, right? And they also bisect the sides. See how they cut the sides in half, right? They bisect the side, whereas these bisect the angles. Call it the circumcenter because it is a circle on the outside. We're circumnavigating the globe, right? We're going on the outside of the world. And it hits all of them. That's the center of that. I think you can tell if I tried to draw a circle with center G on the inside, it wouldn't hit anything, right? So it's got to be the outside. And that means these are radii. Last thing, let's talk about acute, right? And obtuse. Well, that's an acute triangle, right? All the angles inside are smaller than 90. So we're going to call it inside there. Spoilers, all acute triangles have inside centers. For a right triangle, Tucker, do you remember this one from the other day, what you were messing with? When we made that a right triangle, where did that end up sliding? Onto the line, right? It's going to be on the midpoint of the right triangle. So if we have a right triangle like this, here's our right triangle, it'll end up sliding to here. Do you see how if I pulled this, it would push it this way to the halfway point, right? So it's going to end up on the midpoint. And I'll know what you mean by that. Midpoint of this guy, right? On the hypotenuse. And then if I keep doing that, right? We started on the inside, I keep pulling, it went to the side, right? If I keep pulling, where's it going to end up? On the outside, right? It's going to be a center with a circle on the outside. So if I have a big triangle like this, obtuse, the center will be here, and I'll have my circle like this. Does that make sense? It's a terrible drawing, that's why I care about, but that's the idea. See how G will end up on the outside?
Okay, I get it. So a circle, the center has to be in the center of the circle.
Yeah, right?
Yeah.
And so if I drew a circle around an obtuse triangle, center's on the outside, right? On the right triangle, this is kind of cool. It's perfectly in the middle, isn't it? Right? And then for an acute, it ends up being like inside the triangle, right? You can kind of follow it out as you make the triangle wider, right? It kind of pushes it out.
I know, it hurts. He wants me to run and hide.
It's unfortunate those face masks aren't thicker. Thick everywhere. Fresh. Okay? So, for this one, perpendicular bisectors, right? Perpendicular and they bisect the side, right? So perpendicular bisectors. Circumcenter, because the circle goes on the outside, right? That circle is going to be, that center is going to be the center of the circle on the outside. It's all the vertices. Okay? Inside for acute, midpoint for right, and then outside as we go to an obtuse, right? Just pushing it out further and further. If this is a circle, from the center to the circle, right? Radius, all the same. How do you feel about these three? Not great yet, but probably okay, right? Do a little bit of studying. You'll have GeoGebra to mess around with, right? Oh, I don't remember where that center ends up. Well, do your thing, see what happens, right? I wouldn't rely on that, but worst case scenario, I can walk you through that and how to do it in GeoGebra, right? Now, backside we didn't get. We've talked about angle bisectors, we've talked about perpendicular, we've talked about perpendicular bisectors, right? Let's talk about medians, right? The one we like. So on that extra page, let's write 4. Let's draw ourselves a triangle similar to the other ones, kind of like this. Sorry it didn't show up. I apologize for that. All right, everybody. What are medians? Vertex and midpoint. So find the midpoint of all your sides. Now, how do I know those are midpoints and aren't just some random points? I got to mark something, right? So I'm going to do this.
Split the line.
Yeah, split it, right? And median is what to what? Vertice to midpoint. Very good. So I'm going to go to my vertex. I'm going to go to my midpoint. Boom. Boom. And if I did it right, and I guessed for the midpoints, right, I just kind of put down a dot, they should all end up intersecting in the same spot. Yeah, close enough, right? Close enough. Okay? So if I gave you that diagram, those are medians, right? Vertex to midpoint. How do I know it's a midpoint? Cuts it in half. I'm not eyeballing it. It says it, right? So we've got medians. Our favorite, right? Tucker, what's the center of the medians? Centroid. Actually has a different name in everywhere else except America, but I won't bring it up.
Wait, I want to hear it.
You want to hear it? Medicenter. It kind of goes with medians, doesn't it? Right? Medicenter. Right? Medicenter. Ah, right? Yeah. I kind of like that one, but in America, almost everybody uses centroid. Centroid. Center of mass, right? So, we're going to write, it's not center of a triangle or anything, but it is the center of mass, right? You can also write balance point if you want. Balance point on the triangle. Now, what do we know about these guys? The
What
two
is it?
pieces.
Below.
Say again.
After center of mass.
Oh, balance point. Right, it's another way. Either of those I'll accept. What do we know about the pieces of the median? This piece and that piece. You guys remember?
One's bigger.
One's bigger by how much?
By 2.
Double or half, depending on how you're looking at it, right? So this part right here is double the other part. So if you want to on your diagram, you can just do this. 2 to 1. You could also do 6 and 3, or 10 and 5. I don't care, right? 2 to 1 is probably the easiest. Or if you want to write about it, when I've got letters here, you can talk about how like AB is twice as big as BC or something like that, right? Okay. Whatever you want to do to communicate that, it's fine by me. So now let's talk about acute triangles, right triangles, and obtuse triangles. All right, well that's an acute triangle, right? That's what we've been working with to start with. So that's going to be on the inside. All right, not memorization. I know the rest of these. Think about it. What is the centroid? What special property does the centroid have? It's the balance point, right? Is the balance point of an object ever going to be on the outside of the object? Right? If I've got a ruler and I hit the balance point's right in the middle, right? At most, if it's not evenly weighted, I'll have to go like really far to the end to balance it out, right? But will the balance point ever be here? No, right? So I don't care what triangle we're talking about, the balance point is always going to be on the inside of it. Always on the inside. Always. How do you feel? You like that one, right? All right. We got angle bisectors. Why do we call them angle bisectors? They bisect the angles, right? Okay, that makes sense. We call it the in-center because it's the center of the internal circle, right? So you're going to have to know that angle bisectors get you the in-center, right? Why is it called the in-center? Internal circle. If that's an internal circle, those are radii, aren't they? Right? And the radii hit at 90. That's kind of less. Okay, if you missed that, half off. Okay. Inside, inside, inside. How do I know it's always on the inside? Because the circle's always on the inside, right? Right? The center has to be in the inside. 2. We don't like it because it's kind of boring and it doesn't really have like a fun name. It's hard to remember. Orthodontist, right? Orthogonals of the 90 degrees, right? Orthogonal just means perpendicular. Perpendicular means 90. Sorry that we got to learn the other word for it. Orthogonals intersect at the orthocenter, right? And again, if you remember, orthogonal means 90 because when you go to the orthodontist, they straighten your teeth, right? Tucker, go. Acute on the inside. Right angle, well, there's my right? There's my orthogonal, right there. Where does it hit? There. Check it out, guys. Zoom in a bunch. Isn't that an orthogonal, this line right here? Isn't that an orthogonal?
I don't know.
So, oh, sorry. Oh, God. Isn't that also an orthogonal? So 2 of the orthogonals intersect right there. So the third one has to as well, right? It's on the right angle, right? Right angle and right angle, where do they intersect? There. So for a right triangle, oh God, on a right triangle, they intersect at the right angle. Obtuse, well, the height, we have to go to the outside, right? It's kind of weird. That's the weird one. Perpendicular bisectors. Why do we call them perpendicular bisectors? It's perpendicular and it bisects what? Not the angles,
Midpoint.
the sides, right? Midpoints, yep. Mm-hmm. And they go off at random, right? They're not always going to hit a nice point. They're kind of ugly looking, right? So we go from the midpoint on up at 90, right? That's a perpendicular bisector. We call it the circumcenter because it's the center of a circle on the outside, right? Circumference. Outside of the globe, circumnavigate. When it's acute, it's on the inside. They're all on the inside for acute, okay? Right, it goes to the midpoint. Makes sense? That's kind of cool. And then obtuse, it's really wide, so it makes the circle really big, and it ends up pushing the center on out, right? Okay. Cool. If this is a circle, and it is, isn't from the center of the circle always the same? Right? Those are radii. Okay. Medians. Oh, we love them. Our favorite, medians. Midpoint to vertex. Boom, boom, boom. Where they intersect is the centroid, the center of mass. You can also say balance point, right? That's the idea. We know that the segments get divided up into 2 versus 1, right? One's double the other. How do I know it's always on the inside? How? Not because of circle, right? This has nothing to do with circles. Because what? It's not the midpoint. Stop saying random stuff. It is a centroid. Why do we know the centroid's always on the inside?
Yeah, that's what I said first.
What does the centroid do?
That's the
Nope, no circle.
It's the
Center
balance
point.
point.
The balance point. And the balance point's always going to be in the triangle, right? Balance this pen. Man, I'm really bad.
What's that mean?
going to be similar here on the inside. Cool. Medians. Angle bisectors. Orthogonals. Perpendicular bisectors. Are we leaving any out? I think we're good. GeoGebra. We're going to use this as our guide. We're going to make them. Here we go.
Still can't work it.
That's not good.
Yesterday we kind of gone.
Hey, when that happens.
I think I
GeoGebra. Recorded. Again, you can go back and watch this tonight if you want some more help on it. Go to start graphing, and then click the shapes button. And then let me mirror my display so I can sit at my computer and not have to look behind me constantly. I have a million tabs open.
That's happened before.
All right, display settings. Go away, please. All right. Look at your worksheet. What's the first one we made? Angle bisectors at the end center. So let's make a triangle. Go to your segment, make your triangle. Rad. Preferably make acute. I think that's the easiest one to deal with, right? So make sure it's acute. Something like that. Okay. Now let's make angle bisectors. I go to the angle bisector tool, right? I'm going to click C, A, B to cut angle CAB in half, right? I'm going to do the same thing with A, B, C. You can do all three if you want. I don't need all three. Okay? If you want to, go ahead, but two's enough because we found the intersection, didn't we? Put a point there. Now remember, the in center is what we get, and that's the center of what? It's going to be the center of a what?
Gravity.
Circle.
Nope, circle. Inside circle or outside circle?
Inside.
Inside, because it's the in center. So we need to find our radius to make that. So I'm going to go to perpendicular, and I'm going to click the center to the outside, because remember the radii are all perpendicular, right? They hit at 90. Remember that's the weird one you guys always forget about? There we go. So I know that to there is my radius.
Angle bisector, right?
You want perpendicular. Perpendicular.
Oh, no, before that,
Yep, angle bisectors, perpendicular. And then make your circle, circle with center through. So I'm going to click the center and where this intersects. Boom.
so it's bisected and then perpendicular.
Yep, I'm going to start over from the beginning so you can watch, okay?
No.
I'm going to go back.
Left side.
Yeah, Doc, best of luck. Obviously, you will not be taking the quiz tomorrow, okay? Or if you want to, you can, whatever. So angle bisector, CAB. Angle bisector, ABC. Where they intersect, I'm going to put a point. Then I'm going to use that point to make a perpendicular line, okay? This is the part that you guys are going to forget about. After you find the center, go to perpendicular. Pick your point and one of the sides, and it'll make perpendicular there. Boom. So I made my perpendicular. Then I make my circle. How you like the maps?
Oh, wait, I did something.
Better?
How do you, wait, what did you do for perpendicular?
I took the perpendicular line tool, I went to my center, and clicked one of my sides, and now I know that's my radius.
Okay.
So I go circle, center, here. Okay.
Does mine look good? I have like a
Yeah, that's
rectangle over here though.
Which one was your perpendicular? Was it this one?
It's like right there.
Okay, so we're gonna click the center.
Another point, right where the two meet.
Where you click.
Yeah, I just clicked
yeah.
over there.
That's your, two of your angle
So that was the angle bisector.
Yeah.
Angle bisector triangle, right? Because we bisected the angles, and we found a circle on the inside.
You've got to put
In
the
center.
circle on the inside, so you're gonna scroll all the way down.
All right. Next triangle. Here it is. What's the next one on our thing? Orthogonal,
Yeah.
orthocenter, right? So orthogonal means 90, so we're going to make perpendiculars. So grab your perpendicular line tool. We're going to go from vertex to an opposite side and make 90 degrees.
Right.
Wait,
Making perpendiculars. Click your perpendicular line tool, click a vertex, and an opposite side. I'm only going to do 2 at a time. Make it my diagram less messy. So perpendicular, vertex, opposite side. Vertex, opposite side. Those are the orthogonals.
Mine's doing something.
Refresh. Try that.
Same thing.
Where it intersects, put a point. Now, the orthocenter, much like the orthodontist, is boring. Not a center of a circle. It's not anything cool. That's it. Yeah.
We're gonna have like on the quiz, like we have to make this show, like
Right.
we have to actually make the triangle on the paper.
After you make it, I'll teach you how to do a screenshot, and you'll send it to me,
Oh,
okay? So, I can move this around and I can see where it ends up. The orthocenter is inside when it's acute. When it's a right triangle, it ends up on the right angle. And when it's obtuse, it ends up on the outside. I'll do it again from the beginning.
Oh, wait.
Perpendicular tool,
Oh, wait.
right? Vertex, opposite side. Those are all hitting at 90. Intersection
Does
point.
it matter that my intersection's over here?
Nope, that's fine. It's because your thing's acute and it's going to be inside, right? So if I drag this around, notice if I make it 90, it's going to be on 90 degree. And if I make it a very obtuse, right, it's going to be on the outside.
It's
kind of bizarre, huh?
This?
Acute inside, 90 here, obtuse outside. That's the orthocenter.
Not the H.
That's the only thing interesting about it. The rest is boring. So now I'm going to work backwards. All right, next one on our thing. It says perpendicular bisectors. What's a perpendicular bisector? Perpendicular means 90. Bisect means cut in half, right? So we got to find the halfway points on our sides. Go to midpoint tool under construct. Let's find the midpoints of 2 of our sides. So I'm going to click A and B and find the midpoint.
Isn't F already like the F?
Maybe on yours. So I made 2 midpoints, right?
Then you click A, then C.
I could make 3, but it'd make my diagram messy. So perpendicular bisectors. So we bisected the sides, and then we make a perpendicular, right? I'm going to go from the midpoint to 90 degrees. So what I do for this one's kind of weird. I click the midpoint, and I click the line I want to be 90 with. I want to be 90 with this one, right? Does that make sense? I'll go back and do that again. I want to be 90 degrees at the midpoint, right? So I'm going to click the midpoint and that same side to make 90 there. That's what I want. Let's do that again. Midpoint, same side to make 90 degrees there. That's what I want. Remember, this is the weird one that just goes off at a crazy angle, right? So midpoint, same side. I'll drop a point. And now that's the center of what? It's a circumcenter. Big circle. So I need to find the radius, so I'm going to do the perpendicular thing again. I'm going to click center, my vertex. Whoops. I'll try that again. I'll go center to... What did I do? Oh, I don't want center of the vertex. Never mind. Go back, go back. We know our radius. It's from here to here, right? So I go circle, bam. Whew. It's the outside circle. Medians we've been doing a lot. I'll leave that to you guys. Midpoint to vertex, right? Cool.
I said that in lesson. I mean, it looks like it's in lesson, but I don't think that's now.
You what?
I said that in lesson because the words on paper all look like they were in
How do you
lesson.
think you
Yeah.
can do the
It's kind of funny
So
though.
like, I don't
Art.
know. If you need
This
help
art.
with GeoGebra tomorrow, I will help. I can't tell you what to do for certain
Yeah.
things, but if you're like, how do I make it perpendicular?
So
I'm
you
there,
missed
right? How do I find the midpoint?
this.
I'll show you. How do I bisect an angle?
To
I'll show
study
you.
and do that part of it.
So
or
just know what you need
work
for the
on
things,
all of it and work
and then I'll
on
help you
it.
make them in
But
GeoGebra.
it's-
Try to do it next week.
See you tomorrow. Well,
He said he's not quite ready.
oh, Doc, no.
Joey's probably not. either.
Right, and that's fine.
So
If they were
we'll-
absent at all, my policy is you can take it and whatever you get right, great. It's not going to the grade book unless it's amazing.
Yeah.
And then when they do finish it, right, they can come back and do the ones they got wrong. No penalty. So I would probably just say, just don't even try, right? But
Right, let them work on it, and play with it, see if they can figure it out.
the rest of these kids, rude awakening days, like, wait, we actually gonna get put down this. Noticed yesterday, I was thinking about maybe not even doing a quiz on it. And I think most of them that paid attention today realized, right? Okay, now they're doing all right. Because they missed the last day.